Hello dear students and welcome to our tutorial video how to. So this video is about the warehouse assignment, where it's the best location for a warehouse. And let's start. So you've downloaded your data files from Canvas, you've unzipped it, I hope into a folder that you know where it is. So let's start there. So I've unzipped my warehouse data into this directory temp. Then inside temp, so this is what we call the browser panel, and tutorial, and then the warehouse folder that I unzipped. And here is the project file I've prepared for you. Double click on that, and what it does, it opens a new project with the right location of the data. It finds the data that is inside these folders, and it has the right colors. This is all part of this project file. Okay, now that we see our data, we can explore it a little bit. We can turn on or turn off a few of these data layers. So this time we're using real data, so from all of the Netherlands, so it can be heavy on your computer. These are all the shops in the Netherlands. These are the main roads. This is the land use and the neighborhood map. Okay, so the first step is we know that we are only interested in the west of the Netherlands. That is this west, this green area. And the easiest to select is by just clicking here. This is the select features by clicking on it. You can just click on, once this is on, you can just click on a feature. Actually, you have to select the layer you want to, you activate this layer you want to select. I can click on it. Yellow means it's selected. Another way of doing this will be to right click, open attribute table, and then here you can select one of the records. So either way, now it's selected, we're going to export it, export, save selection feature there. So it makes a new selection, a new layer from the selection. And let's keep it as a shapefile. Give it a name, West and L. We put it in the right folder actually. Let's put it on the same place. So C, temp, tutorial, warehouse, and we put it on inside vector. And or we create a new folder called results. Results, and then West and L, save, and everything else. Save only selected features. Yes, that's great. And add saved file to the map. Okay. And there we go. We have a layer with just our West NL region. So it was important to have just the West NL region because we want to locate our warehouse in an industrial site in West NL. Because now we're going to do is going to look for industrial sites. As you can see here, the land use, PBG, PBG, so bestaande bodemgebruik in Dutch, land use categories. And there we go, we have a category called industrial. Well, I've translated this to English, but when you right click and open attribute table, we can see this is the original data set that I downloaded from the Bureau of Statistics. And you see here the names of the different main category. So this is built up, about, and if you go down, then you see bedrijfsterreins, which is industrial, was. So all these different categories. And now we want to select only the industrial sites. And for that, we're going to use an expression. So this button here, select features using an expression, allows us to say, okay, now I want to create a new layer with just the industrial sites. So the expression, I go to the fields. So which field am I interested in? I'm interested in this main category, hoofdgroep. When hoofdgroep is, and I'm going to ask for all unique values. So when this is selected and I click all unique, then I get all the unique values. So hoofdgroep is bedrijfsterrein means, so main category is equal to industrial sites. And I say select features, and we're done. Oh, it's too busy, now we're done. Close. Now it says here, features total 15,000, filtered, same 15,000, selected, 10,000. You see? Oh, actually, it's not 15,000, it's 150,000. And selected 10,347. Yeah, so we can even say, show me only the selected features. And there we go, all our selected features. Now we want to make a new layer from only these features. So again, we know how to do that. We right click, export, save selected features as. Now we call it industrial. Add save to the map, only selected features. Okay. There we go. Let's turn off this one. Now we have industrial sites, only industrial sites, but we only care about industrial sites in West NL. And because we only care about industrial sites in the west of the Netherlands, we have to clip these features from everywhere just to these ones, just the ones that overlay with the west region. And there's the clip function for, we go to vector, geoprocessing tools, clip, and you choose industrial sites. That's what we want to, our input layer, our dough for our making cookies. This is our cookie cutter, the overlay layer, and that we want to be the West NL. And we are going to clip it to a new temporary layer, save to a file. Again, C temp, and then tutorial, then warehouse results, and now we call it West. Save, and now run. Now, this is interesting. The data that we downloaded from the Central Statistics Bureau gives an error. Oh, yeah, I couldn't clip it. If you look carefully, one feature, 5048, has invalid geometry. Please fix the geometry or change the processing setting to ignore invalid. Then I don't know if this is a very important feature. We could go and find out. Maybe we can remove it because it doesn't matter. But I think the nicest in this case is actually to fix it. Invalid geometry is likely that the polygon didn't close because it had point, it didn't close properly, and then it doesn't know if one of the points is inside or outside our area of interest. So let's try that first. So we're gonna close this, well, we can leave it open actually. We just go and say fix geometries. There's a tool for that. In vector geometry, fix geometries. And then it's our industrial site we want to fix, and we're going to call it industrial fix. Actually, we have to click here to save it to a file. Same location, indus fix. Save, run. Okay, close. Now we have one more layer called indus fix. And that's the one we should use because it should have fixed that issue there with the invalid geometry for one of the polygons. Choose this one as input, industrial fix. West is our shape, and we do it again. Loading results. Yes, now it's done. It completed it correctly in 1 second. Close. Let's have a look. So we turn off this one, and there we go. All the industrial sites inside West NL. So now we have a layer with all the industrial sites in the west of the Netherlands. But we don't care about any site because some sites are really small, some sites are really big. We care about a big enough size. So we know from the board of directors they want to build a big warehouse. So it doesn't make sense to look in the very small areas. So let's add that as an extra parameter in our analysis. So we want only the areas that are big enough. We go to open attribute table, and again we're going to select by expression, but this time what should the expression look like? Pause this video and think about it for yourself. What should it look like? Well, if we look at our table of attributes, we see that we have main category, we have shape length. This is in meters, so the length means the perimeter, so the meters of the border. But we also have shape area, and this is in square meters. And this is the one that we need to use. So we're gonna use this one for calculating our right area. So again, we need a field then. In this case, it will be area. And when the area is bigger than 50 hectares. But 50 hectares, if we use to 50 meters, everything will be selected because it's not, so we have to convert 50 hectares to square meters because our data is in square meters. And we know 50 hectares, so 1 hectare is actually 100 by 100 meters, so it's 10,000 meters. So we need to add 1, 2, 3, 4. That's it. Select features, and there we go. Let's have a look at our results. Something was not selected. Aha! I actually did the smaller than 50,000. We want bigger than 50,000, of course, larger than. And now we're gonna say select features again, and indeed it inverted it. But looked very strange, the result. Let's have a look at it in the map. Yes. As you can see here, big area selected, small areas not selected. Great. Now we want a new layer of this selection. We right click on this, export, save selected features as, and give it the proper name. See, temp, tut, warehouse results, and we call it industrial west 50 plus. Save, and okay, there we go. Now we remove everything else. Now we have all the sites which are big enough for our warehouse, and we did West NL, but there's still a lot. So now we have to think about how can we still select, do we want to be here or here or here or here? So let's think about the next steps will be what will be our preference. So this was the constraints so far. The next one will be our preferences. The next step is indeed to look for available personnel. So we want to locate our warehouse close to where people live. And so we're going to look for where could we find most people that are interesting for us. And for that, we have a data set that we also downloaded from the Statistics Bureau, and is this one. And it shows all the neighborhoods in the Netherlands, and with extra information per neighborhood. So if let's have a look at the table of contents. So some neighborhoods are really small, some are really big. But as we can see here, it has a lot of information. This table of contents. For each neighborhood, it has the codes for the neighborhood, but also the name of the municipality that it's on. Let's look more. If it contains water or not. Remember, every time there is minus 9999, it's a code from the Statistics Bureau representing no data. And no data is different from zero, by the way. So it means I don't know, or I don't want to tell you. Because a lot of these statistics, if you have less than 5 people living in a certain neighborhood, they prefer not to tell you the information because it's sensitive. So they will replace it with this code -99999, which is no data. So some very interesting statistics. So these are the most important for us. Total inhabitants, aantal inwoners, and then aantal man, so number of men, number of women, female, male. Then what else we have here? We have also percentage of people between 0 and 14 years old. So we have 14% of this total inhabitants. 14% is between 0 and 14 years old. And between 15 and 24, 14% again. And between 25 and 44, 27%, and so on and so on. This was the age, a percentage of people married and not married. Just let's go here, married, not married, and then more information, a lot of detailed information. Percentage of people coming with a migrant background from the West. So have a look at the metadata from this data set. I also included it in the zip file. So you can learn about all the different information on this data set. Very rich data set you can download from Statistics Bureau. And towards the end, we also have, oh, this is funny. I've created this data set and I've tested it for you, and it already has the columns that I tested. I should have removed them in the end. Let's do that now. Edit, remove columns, delete fields, and I'm gonna remove. You don't have to do this, but you can also remove. Okay. And it's removed. Now I'm gonna save it. Well, I don't have to save it, but okay. Now this is what you should have gotten. So information about no extra information. So this is it. What we got from Statistics Bureau. And now what you need to do is to calculate the people that we're interested in, our potential personnel, and that we do with our field calculator. And if you remember, so we're going to create a new field. Let's call it personnel. And we want people to work in our factory, but they have to be between 25 and 65 years of old. And do we have that? Let's go into our fields. Do we have here people living between 25 and 65? No. We have between 15 and 24, 25 and 44, and 45 and 64. Okay, that's something. So let's do that. So we know this is percentage, but we know we want this group plus this group. So now we have the percentage of people 25 and 65, but this is a percentage, of course. So we'll have to multiply this by our total inhabitants, which was this one. Let's multiply that. But this percentage was not 0.5, but it was actually 50. So we, in the end, have to divide the whole thing by 100. Okay, now we have the number of people from our appropriate age class in this new field. Okay. Takes a while. It's many different neighborhoods. Okay, let's have a look. And great. So we have 56 people living in this neighborhood, and what else? 400 here, 600 there, 4,000 here. So of course we want to be closer to the areas with most people. But actually, so it's normal that big areas will have more people and small areas might have less people. So so this is not so much fair. So what we wanted to have is some sort of density. So in that sense, we want to divide the number of people by the size of the neighborhood. That would be more fair to compare the different neighborhoods. And therefore, we're going to again calculate fields. So let's stop any selections, because otherwise it only works on the selection. So deselect all here. Now we're going to calculate a new field. And this time we're going to create a new field. We call it area, because we don't have the area of the neighborhood as one of our attributes, do we? I don't know. Let's have a look. Area, the beginning? No. Okay. Then we have to calculate it. New field called area, and we want this field to be equal to there's actually expressions here. We can use a geometry. This one returns the area of the current feature, and we double click, and so it's a $area. This is a code for the QGIS to calculate the area of our polygon and put it on our row, our each record. Let's see. Okay. It's a little bit. I think we're done. No, still busy, 73%. 100%. Okay, task complete. Let's have a look. Okay, so this is the area in square meters. How do I know it's square meters? It will be the same units as our map. And our map units, so if we go here and say properties, and we can see in information, we have information about the data set. And there we go, unit is meters. You also have the projection, you have different type of information, all the different attributes it has. Okay. Now we know it's in meters. Let's go back to our table. Now we want to divide the people by the area. But one thing happened when we calculated the people. Did you notice? Remember the code, the -9999, the data that didn't want to give it to us? If you use it to calculate our people, you get this -50000. You get these strange numbers here. And we don't want that. We don't want to have negative people. We don't mind zeros. There's nobody living there. But you don't want these negative people. So what we have to do, we have to select from our personnel. So let's go back to the fields. Personnel. And every time that you have that the personnel is smaller, this time smaller, than actually 0, select it. Let's do that. Select features. Correct. So every time there was like these negative numbers is now selected. Now, what can I do with this? I can now again calculate the geometries, but this time I'm going to say only update the selected features. So yes, that's great. So every time that I have selected features, I want it to be no data or 0. Doesn't matter. If you want to create no data, I type in none. And there we go. Then I say, so I have to say update an existing field, of course. Update an existing field, and this field is then the, what did we call it? Personnel. Okay. So update existing field personnel. If it's selected, change the value to none. Or change the value to 0. This makes more sense. So we think there's nobody there. I'm going to say OK. Okay, so we got rid of all our negative values. And now we can divide, we can calculate our density. And our density is now the number of potential personnel divided by our area. Again, we're going to use field calculator for that. And we create a new field called density, or personnel density. And we need the field calculator, the field that we're interested in, which in our case is personnel divided by the area. But the area is now in square meters. actually it's not so handy to report people on square meters. It would be better to calculate people per hectare, for example. Okay, so how do we do that? Take a moment to see. Well, so we know that 10,000 10,000 square meters is equal to 1 hectare. Okay, so if we know that, then what we should do is our square meters, if we divide it by 10, 1, 2, 3, then we'll have our area in hectares. And then we have personnel divided by the area, in this case in hectares. Let's try that. Okay. Still busy. Okay, I noticed that I already made a mistake. Do you know which mistake I made? No, I can tell you. So everything is null now. Do you know why? Sometimes it's nice to go back because I had things selected. Remember the negative values were selected? And when I press this compute, it says only update the 900 selected. Ah, that was a mistake. I didn't want that. So now what I want to do is to update all and create a new field. No, I want to update the field, and the field that we just created is called percentage density, and we do the same function. Fields. Sometimes it's nice to see errors so we know where they come from and we know how to correct them. Then we have personnel divided by our area divided by 10,000. Let's put the brackets to make it more clear what we're doing. Personnel divided by hectare, by area per hectare. All features will be updated. Let's go for it. Yes, now we have people per hectare. 1, 1, 10. Let's sort this all the way up to 245. Okay, let's remove this selection before we get in trouble again. Deselect all. Now, that's it. So now we have this. So let's actually visualize our data set with these new features, with these new attributes that we have. I'm going to save it and stop editing. And now we are going to close this one. Still editing, so stop editing. And now we're gonna visualize it. So in the symbology, it's not single symbol anymore. We want it to be graduated, and we're gonna ask for which value we want to graduate it on. We just said on the density, and we say classify. We'll create different classes for us. Apply. Okay, yeah, makes sense. So Amsterdam, very high density, lower in the countryside. Great so far. And that's exactly the next step. Make a pretty map of our workforce. Let's do that now. We can change the symbology here. For example, we can remove the stroke into no pen. Okay. Again. And again. Stroke, no pen. But it will look nicer. Otherwise, this is very dominant. And finally, no pen. Okay, apply. Yes, looks much nicer already. And we also would like to have the western L on top, but we want it to be hollow. So this one we'll choose, apply, okay. Actually, let's change it the color. Okay. And we put it on top. And this is more or less the map we want to do. And you should go to print layout. You know how to do that from the previous tutorials. Personnel, okay, and we then create a new map. We add the map, then you can add more items such as a scale bar, such as the legend, of course, it's the most important one. Well, actually there's too much stuff on the legend. We have to remove some of the stuff. And if you want to change the names to better names here, the easiest is that you change them here on the layer name. So if you rename the layer, rename West NL region, enter. Now when you go back to our personnel, it should then update. If it doesn't update immediately, click on refresh, and there we go, it updated. And go on, put in a north arrow, a title. But if you're delivering a report, you don't need a title. You should put in the figure caption report. If you're delivering a map, then the title is necessary. Okay, good luck for that. And I think that's it. We just arrived to the end of part 1.